the sign on delta math rather distinctively. And let's go. So today we're talking about continuity unknowns in indeterminate forms. Okay. So continuity. The first problems are going to be very similar to yesterday's problems. All right. So in yesterday's problems, in terms of review from yesterday, I gave you an example and it went something like, 3x squared plus 1 for x less than or equal to, let's say, 2. 13. And 5x plus 3 for x less than 2. And in yesterday's problem, the question went something along the lines of determine if continuous at, and the point that of course we're going to study is at x equals 2. Now the nice thing about, so this is a piecewise function, f of x equals, and the idea being from piecewise is that the function will look like 3x squared plus 1 for values of x less than 2, so it'll look like a parabola. And it'll look like 5x plus 3, which is a line for values, oh, oops, I got that backwards, x greater than 2. I meant to flip the signs so that we're not doing the same ones. So it's like a half parabola, half line, which are both continuous. And if you don't fully understand, it's okay, but I do, if you want to master it and you want that 5 on the AP exam, the reason why continuity or continuous functions is important is because that is the reason why we can plug in. All right. So we want to determine if this is continuous. And most people will do the following. They'll just go 2 squared plus 1. And they'll just plug into right there. And then on the other side, they're going to do 5 times 2 plus 3. All right. If this is a multiple choice problem, this would be enough to give you your credit. All right. However, I want to make sure that I give you the best education possible. I want to make sure that I get you the ability to get the 5. And so, well, that's technically what we're going to do, is we're going to be technically plugging in to here. What we have to realize is that we're going to find the limit as x approaches 2 from the left-hand side of f of x, which is the reason why I'm plugging 2 into the 3x squared plus 1, because that's the left-hand limit. And then over here, I'm going to take the limit as x approaches 2 from the right-hand side of f of x. So I'm really finding the left-hand limit and the right-hand limit for these two functions. This left-hand side gives me 13. And the right-hand side gives me 13. So, is this function continuous at 2? At x equals 2?
Yes.
Yeah. Well, so here's the hard question. So, like I said, and this is where calculus can get a little bit difficult. You got the right answer. If this is a free response, getting the full credit, I have not shown enough work to get full credit on the AP exam for a free response question. First and foremost, we have to remember there's layers to these questions, okay? Answer, yes. But there's also always just this little thing that's off. So can anybody tell me why it is continuous? Remember, there's 2 criteria. Kayla, you wanted to take the chance? No? Somebody else?
I said the equations.
The equations. Okay. Mm-hmm. So typically we have to say that the limit as x approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right-hand side of f of x. Basically, that's what Kayla was saying.
So those are the same?
They're the same.
That's a reason, because they continue But when I do, when down the say it's not continuous.
When the left-hand limit equals the right-hand limit, that is
It's
almost.
1 or 2.
It's almost. It's
Yeah.
almost. It's not the answer yet. We haven't finished the answer. There's one thing missing from this answer. Can anybody recognize what's missing from this answer? It's very minor. And I've actually seen an AP problem that asks you to show your work. And most people, 9 out of 10 students that don't understand what the question is talking about, do this, and they stop. And then they lose half credit. It's ridiculous how much credit they'll take away. What is the other criteria?
Don't you have to write that sentence? Is that what you're talking about?
It's not a sentence necessarily. It was those, if you looked at the top of the notes from yesterday, it was the 2 criteria. So that was the first criteria. And the other one, and I'm just going to go with it, is that it equals, and it's very small. It equals f of 2. So when the left equals the right, that means that they bring towards each other. But what could happen is that there's a hole, a hole that's in the middle. So we just have to confirm that's f of 2. And how do I know what f of 2 is? If I look at the very top here where it says equals, because of this, f of 2 will also equal 13. So it's just this little piece right here that people miss for it. Now, this is only the case where I ask you to explain for full credit. Left-hand limit, and you have to use the left-hand limit notation. Right-hand limit, you have to use right-hand limit notation. And then you also have to make sure that you're showing that they're equal, and also that they're equal to f of 2. That's full credit. That's a 5. If you got to understand, and a 5 is considered a perfect score on the AP exam. In reality, you only need about a 75% to get a 5. A perfect score on the AP exam is typically considered a C. You get a C on the exam, you got a 5. A 65%, which is like a D, is typically a 4. A 55%, an F plus, is considered a 3, which is passing, which will typically give you college credit. Now, if you were able to show me that you got 13 from the left and 13 from the right, and then you said, therefore, it was continuous, while you won't get 100% of the points, you'll get the majority of the points from me. But if you want the full credit, you need to, have the limit notation, and you have to remember equals f of 2. So that was yesterday. We're going to do a problem very similar to the one up top, but what I'm going to do now is I'm going to actually, what happens, well, let me write with the example here. So here's the example, and it's going to look nearly identical, okay? G of x, I'll put G, just to do a different letter, is equal to 3x squared plus 1 for x less than or equal to 3, and cx plus 3 for x greater than 3. So C, oops, wrong color. I wanted to highlight. C is an unknown. So what I'm telling you here, and the difference between this problem and the previous one is find the value of C that makes g of x continuous at x equals 3. Or we can word the problem in other ways. I can tell you g of x is continuous. Okay, I can say g of x is continuous everywhere. Find the value of c. That makes that statement true. So in the previous problem, c was 5, but that's what x equals 2. Now we're going to do the work pretty much identical to what we just did. And that's a reason why I did this previous example. So we're going to follow the steps almost identical to the previous problem. What do I do first? What am I going to find first?
Are you going to plug in 3 for the top equation 3? Yeah.
Yes. Correct. 100% correct. Can anybody give me the more the notations just to start off with, because if I want to get that full What are we doing? When I plug in 3 into the top, that is mathematically what we are doing. 100%. You're right. But what are we doing? Like, what is the concept that we're finding? The concept is that you're finding the left-hand limit. That's what I'm looking for. The limit as x approaches 3 from the left-hand side of g of x. That little piece right there, that's the technical part, okay? If at minimum what I'm looking for, especially since we're remote learning, is exactly what was just said. I'm going to plug 3 into the top function. And if you do that, you know what? We can be successful. We can work from there. The next layer that we would work on is adding this little piece right here, which so we get 3 times 3 squared plus 1, which is 9, times 3, which is 27, which gives me 28. Okay, what am I going to do now? What is my next step?
The number C was a CX plus 3.
Okay, perfect. Where am I going to plug in the 3 for?
And the X.
In the X, and that's very critical. We're trying to find the value of C. So, and I have students that do this. They'll plug in the 3 for the C by accident. So just as it was said, it's equals 3 times, oh, sorry, oops, I just did it. 3 times 3, oh, I just did it again. See, even me after, because it's been a while. C times 3 plus X, plus 3. I want to make sure that I see a C, because I'm trying to find C in my problem. Now, of course, if you want to fully get full credit, limit as x approaches 3 from the right-hand side of g of x. That's the technical part that we're finding. Which gives me what?
I think so. 6.
No, we got to be careful with our algebra, okay? So we got to be careful. We can't combine these. So we can't, and so it was a little bit of a trick question, a little bit mean maybe on my part, but it's a trick question. We just get 3c plus 3. And the reason why I asked that question is I want to make sure, especially since it's been a while since we've done these type of algebra sometimes, is that c times 3 plus 3 is, there's nothing that we can do to clean it up. There's nothing that we can combine. We can't combine the 3 with the 3c. We just get 3c plus 3. Who wants to take a guess? Who thinks they know what we need to do to find the value of c?
I'll try.
Okay.
28 equals 3c plus 3.
Perfect.
And then you minus.
Oh, okay. Hold on. You're going a little too fast for me. So I'm going to minus 3. Yep. Yes. It's just algebra here. 25 equals 3c. And what do I do now?
Divide by 3.
And so my answer is c equals 25 over 3. And that's my answer. Now, sometimes the C could be in any location, okay? The C could be located here. That's an ugly color. Let me get something. The C could have been here, like it was in this problem. I could have put the C here. I could even put the C here and put it 3c squared. Or I could have even put the C out here and left everything normal inside here. So I could have actually located the C in any of these spots. But if you follow the process, you plug in this number wherever you see an X, and you do the same for the other side, it'll give you 2 expressions to which you're going to set those equal to each other. Now, to be technical, to get a 5 on the AP exam, we must understand that the concepts we're doing is left-hand limit and right-hand limit for there. Now, notice that I didn't say anything about the g of 3, but it should be, if it was asking you, this problem wasn't asking you to determine, but because there's an or equals to, whatever we got for the first part would have been, you know, g of 3 as well.
So why is 25? What?
28 minus
That's
3.
it. 20 minus 3.
28
No,
minus
that's
3.
You put 26 at all.
There's no 26.
I see the same 26. You know, change.
Oh, it's just the right let me just clean that up. Like that? Is that better?
Yeah.
Okay. Yeah, that's a 25. All right. How are we doing? So that was 20 minutes. Okay. So there's our first part of our lesson. Let's talk now about the indeterminate form. And we're not going to get into the super complicated ones. We're going to take away those complicated ones that I would traditionally give in a normal class. And we're going to focus on the basics here. So first off, what is an indeterminate form? And if I get an indeterminate form, what do I do? So indeterminate forms, what we're going to be working on, come from rational functions and removable discontinuities. Holes. All right? So what I mean there is that while the value f of a may be undefined, the limit as x approaches a of f of x may exist. That's the whole concept here. So there's a difference that we have to understand between the evaluation of a function at x equals 3, what is the value, or at x equals a, what is the value, which is different than the limit. What happens as we get closer to a for the function? So for example, yeah.
What does that word say next to may be?
UND,
Thank you.
undefined. So it's capital. It's our. So when you type in something in the calculator and you get undefined, typically that happens when you divide by 0. Okay, good question. All right, so here's what the problems look like. Typically, we're going to take the limit as x approaches a of a function divided by another function. So it's like this. Now, don't overthink it. How do I find the answer? What do I do? If I was given this type of problem, what do I do to evaluate a limit? We're not looking at a graph. How do I find limits analytically? Don't overthink it. How do we find these values? How do we find this limit? How do we find that limit? What did we do?
We plugged in the given number.
That's it. Yep. Plug in. Basically, when you find a limit, the first step you typically always want to do, if you have actual functions, is we want to plug in. Now, in an actual problem, you wouldn't be given f and g. You would given actual functions in their place. So we would get f of a over g of a. But what the question is, when we get 0 over 0, this is the situation we're going to be focused on today. 0 over 0 is an indeterminate, is what we refer to as an indeterminate form. And basically what that means is that the limit may exist. We need algebra help. So number one key takeaway. If you get 0 over 0, does that mean the answer does not exist? First and foremost, if you get 0 over 0, if you plug in and you get 0 divided by 0, does that mean that the limit does not exist?
No.
No, it doesn't. That's the key first thing. No. It means that it might exist. Does that mean the limit will exist? Also no. But it means that most likely I have to do some algebra. Now, over the summer, for my Bridge to Calculus class that we offered to everybody to take, and some students took on of doing that work on the summer. The base premise, and you don't really need to know this, but it does help you grasp a little bit more understanding, is that when I plug in A, if I get 0, when I plug in A, that means that x minus A can be factored out of both the top and the bottom. So the whole key concept here is that because 0 over 0, we can factor an x minus A to cancel. That's not how you spell cancel. That's like uncle. Cancel. Cancel x minus A and reduce. That's the big concept here. So it's just algebra, and if I'm not going to put it crazy hard. The biggest thing here is the main thing here that you may struggle with. That's a prior topic. Is factoring. You might have to factor quadratics. You might have to expand and then factor. The main key here is doing good algebra. And you're in this course because you were strong in your algebra. And we're not talking about like the algebra that you may have missed at the end of the year. We're talking about 9th grade algebra. We're talking about 10th grade algebra. Those type of factorings, binomials, most likely factoring is typically what we'll see in here. So here's my example. I want to find the limit as x approaches 1 of x squared minus 1 over x minus 1. Okay, that's the problem. What's my first step?
Plug in 1.
Plug in 1. Yep, don't overthink it. Always plug in 1. Or because it's 1 here in this problem, right? So I plug in 1 because it says the limit as x approaches 1. 1 squared minus 1. I prefer that you show me the plug-in part. You don't have to show me step by step. If you can properly do the math in your head and state that it's 0 over 0, that's okay. But sometimes I'll give you this same type of problem, but I might say the limit as x approaches 2. And some people go, oh, 0 over 0. Well, if I plug in 2, I'm not going to get 0 over 0. I'm actually going to get an actual number. I get 3 over 1, which is the answer. So you just got to be careful. Plug in, make sure what you get. Now, I got 0 over 0. This means what? What does this signal?
That it may exist, but we need algebraic help.
Need algebra help. May exist. All right. So let's do some algebra. What can I do with the top part? So I'm gonna restart the problem. Limit as x approaches 1. Okay. But I'm going to factor. So what was the top? This is called a perfect square. Can anybody remember how to factor x squared minus 1? Now, please do not cross out the x's. So some bad algebra happens, and if you're getting that answer, work with me. I can work with you on factoring. I can assign some Delta Math practice on this as well that just focuses on factoring. If you're struggling on skills like factoring, it's the real answer so that we can continue with AP Calculus and not have to reduce it down to something else is we need to put in the work, which means you might need to review it. So how do I factor x squared minus 1? Can anybody recall?
X plus 1, X parentheses, X minus 1 parentheses.
Perfect. This is called the difference of squares, and the answer is the conjugates. X plus 1 times X minus 1. Now, typically when I do this, because I know I plugged in 1 and I got a 0, I know one of the factors has to be X minus 1. So I usually write it like this. They're both the right answer. And the bottom, oh, the bottom's set. The bottom is set. All right, what happens now? What happens algebra-wise?
You can cross out the X minus 1 on both sides.
Good, so this now gives me the limit as X approaches 1 of X plus 1, which gives me, what does that give me? How do I do it now? I got a new problem. Now when I finish, when I've done algebra, I just plug it back in again. Don't overthink it.
Plug in 1 for X.
1 plus 1. And my answer is 2. So, plug in. If you get 0 over 0, we need to do algebra. After you've canceled out what gave you that 0 in the denominator, replug in. And you have your answer. Let's try another algebra problem. Limit as X approaches 1 of X minus 2 squared minus 1 over X minus 1. Okay. Step 1. What's step 1?
Plug in.
Plug in. 1 minus 2 squared minus 1 over 1 minus 1, which gives me negative 1 quantity squared minus 1 over 0, which gives me 0 over 0. Are you always going to get 0 over 0 on these problems? No. Yeah. So no. That's why we have to make sure that we've done the algebra plugging in so that we get 0 over 0. Doesn't mean we will. All right. So now what do I got to do? What do I have to do? Who's my good old friend right here? Who's going to be my best friend on this to work on this problem?
Algebra.
Exactly. My good friend algebra. You'll see that happen quite a bit. I got to just do algebra. Now, this is now the limit as X approaches 1. And I've done this example purposely. I cannot factor out. First off, I can't cancel. Some people will try to cancel out certain things. Like, once again, they'll try to cancel out the minus 1s. Canceling out doesn't work that way. I need it to be an entire factor. Before I can factor the top is not factored. It's partially factored, but it's not factored. What do I have to do to the numerator to factor it completely? Because it's not what we considered factored. What do I have to do to the numerator in order to factor? I often call this, sometimes you need to take one step back to move two, you have to move back a step to move 2 steps further. What do I have to do? I only got 2 minutes, but I'll move forward for us. We have to expand. And of course, you're like, well, how am I supposed to know that? I know, that's why I do this example so that you can see. It's algebra. So we need to expand it. When I expand x minus 2, this is the same thing as x minus 2 times x minus 2 minus 1 over x minus 1. And if you know how to expand it without writing x minus 2 times x minus 2, you feel free. That gives me x squared minus 4x plus 4 minus 1 over x minus 1, which then becomes the limit as x approaches 1 of x squared minus 4x plus 3 over x minus 1. So the top expanded is x squared minus 4x plus 3. I have to expand it to a quadratic in standard form. All right, how do I factor out the numerator now? Does anybody know how to factor out that numerator? Well, what do I know is one of the factors? What do I know guaranteed is one of the factors?
X minus 1.
Perfect, guaranteed, every time, if you've done this right, because that's how we got 0 on the numerator. And what is the other factor?
X minus 3.
X minus 3. If you need help with quadratic factoring, I can give you some extra practice and lessons on Delta Math. I'm also, like I said, office hours. They cancel each other out. I now have the limit as x approaches 1 of x minus 3. And I finish by plugging in 1. 1 minus 3, negative 2 is my answer. It is 8:50. That concludes our lesson for today. You have your Delta Math homework, which applies these two problems